Good morning, everyone, and welcome to the second webinar of the 2023 Innovation in Motion webinar series. Thank you for joining us today. Today's webinar focuses on several tools to improve traffic operations. We hope the information shared today will positively inspire ideas to gain that extra edge on the job and in the transportation community. My name is Jacqueline Huss with PennDOT's Bureau of Innovations, and I'm your moderator for today's session. Before we get started, I want to review a few important housekeeping items. All attendees are muted during this webinar session. If you need closed captioning, please select the closed captioning icon in the lower left-hand corner of your screen. A question-answer period will follow today's presentation. If you have any questions during today's session, please use the chat box in the lower right-hand corner of your screen to submit your questions. Before we begin, please be advised that this session is being recorded. If you ask a question or comment in the chat box during the session, please note that by doing so, you are consenting to the recording, retention, and use of your statements recorded as part of this session. I'd like to kick things off with introducing our speakers for today. Our first speaker today is Ryan McNary, Chief of the Traffic Operations and TSMO Performance Section in PennDOT's Bureau of Operations. Ryan will provide an overview on the lane reservation system and freeway evaluation Pennsylvania system, also known as FreeVal PA. He will also share updates on two Federal Highway Administration Everyday Counts innovations, advancing next-generation traffic incident management and crowdsourcing for advanced operations. Scott Benedict, our second speaker, is the Manager of Traffic Systems and TSMO Performance Operations in PennDOT's Bureau of Operations. He will be sharing updates on the Regional Integrated Transportation Information System tool, which is a software platform used to generate measures based on travel times. Welcome, Ryan and Scott, and thanks for being with us today.
Hello, everyone. My name is Ryan McNary. I'm the Chief of Traffic Operations and TSMO Performance. Thanks for joining the Innovation in Motion webinar. Today, we're going to be talking about how our office has been harmonizing traffic operations information and data to advance and bridge that gap with safety. So I'm going to be going over three different topics during this session, one being the lane reservation system, and then two others. So initiatives for advancing TIM, and then how we're using crowdsourced information to advance traffic operations. Both of those last two fall under our Everyday Counts initiative with FHWA, so EDC 6, if you hear me say that. I will try not to do many acronyms, but it's difficult because there's so many things, and here we go. But we're getting into the presentation agenda. I said already, we're going to be going over the lane reservation system concept of operations, the conceptual design, and then where we're at with the status of the timeline. Next gen TIM, or traffic incident management. So data-driven incident research, how that corresponds to our operations implementations, maybe some data to show you on that. MVIEW is a video sharing software that we have for first responders in partnership with Maryland. So we got that around 2 years ago now, and I'll give you a status on where we stand with our partnerships. And then what we're working on for next gen data sharing. This is pretty much the future of transportation and how we can communicate with connected vehicles, for example. From there, we're going to be talking about how we're using connected vehicle data or crowdsourced information to advance our operations. So we were one of the first in the nation to have a data-driven congestion pie chart. We'll be going over that a little bit, where we've taken that to, and the analysis that has allowed us to look into the virtual queue protection applications, and then where we stand with just a simple alluding to the origin ingestion data set that Scott will be talking later in this session. So getting right into it. A lane reservation system, or lane closure system in many other states around the nation isn't a new thing. It's something that has been in concept or has been used for decades. The concept around it is essentially you just want to know where people are taking capacity on your roadway so you can do more proactive traffic management, protection of the workers, protection of the motorist approaching in those areas operationally. So with all that situational awareness, we can do a lot more to route people around it and then stay in our core goals for what we want to do here in traffic operations at PennDOT of moving people more effectively on our roads. So by the numbers, what does it look like for work zones that happen on PennDOT roads? So starting on the left-hand side, we have causations out of our road condition reporting system. Right now, it's our current incident management system. So we have road work, moving road work. An example of a moving road work would be line painting, for example, or trash cleanup, sweeping, sometimes mowing, but generally that's a little more stationary. Utility work, it's pretty self-explanatory. Anytime, any utilities being worked on our right of way, they have to come take capacity on our roadway. So averaging around 40,000 of these on all our routes per year. And then if you look at our core roadway network or our core network only, if you hear me say that throughout this presentation, what that means is there's 4,000 miles of roads that we've deemed critical, and we call them our core roadway network. That's our limited access, our major arterials, our interstates, for example. So if we lost those type of routes, it can have very high detrimental effects on that region, for example. So it's all in our recent past. It's still in our memory, maybe. Losing 995. That would be an example of a core roadway network route in the Philadelphia area. But the graph you see at the bottom shows you by time of day when these are entered. And you see a big mountain there around between the 6 and the 10 a.m. time frame. That causes a lot of excess work by our TMC operations staff. So TMC, what I mean by that is a traffic management center. We have 4 regional traffic management centers around the state that operate 24/7, 365. They are constantly trying to manage the traffic to make sure our motorists, our public motorists, our workers are protected, and we can route people and protect people as safely as possible. What that amount of magnitude of incident information and or road work coming during that time can do is cause this. I see it more often than not during this time frame, just trying to do too much. And I think technologically wise, we are at a point now where we can start to change our systems to help these 24/7 operations staff out better. So right now, our current policy is phone call into the TMC when a work zone is going live. So when you're getting thousands of phone calls throughout the year during that time frame of the morning, at that point, you can't proactively manage the traffic during one of our peak times. So that is pretty counterintuitive to the core goals of what we want to do at PennDOT traffic operations. So one of the core responsibilities is they have to capture all this information into the incident management database. So it's a lot to do during our peak times. And what we hope to do with the lane reservation system is cut down on that and hopefully get ahead of that curve where this information can be entered in advance, for example. So getting into the very high level concept of this, all you probably might have heard of this before, open table. So open table is used by a variety of different restaurants to allow you on the internet to reserve a time. You go to their website, they utilize open table. You put in the number of people, you put in the date and the time that you're considering. It gives you the best time that they can apply, or you can apply, I'm sorry. Essentially, restaurants have capacity as well. just like our roads. So this concept takes into a capacity of transportation, was what we're going to relate this to. So the highway capacity manual is something that's well established, where we can understand by the number of lanes and the number of travelers on those lanes on average, what type or levels of congestion or hours of delay we could expect if volumes hit certain times, for example, or if you take capacity per said work zone. So currently in Pennsylvania, we have what we call the FreeVal PA system. So it's a sketch planning tool that allows our designers and our traffic folk to understand when would be the best time, or these are the times that if you're going to do this type of work, it would cause X, Y, and Z to your user delays on the roadway, the motorist delays. So the concept here is we're going to be joining our FreeVal highway capacity manual based conflict monitoring within the lane reservation system. And we're going to take that even a step further, is we're going to have traffic volume profiles by hour. Now, traditional highway capacity manual is just based off general average. We can do a better analysis here. So overall, we think that this will essentially be able to automatically calculate around 80 to 85% of the conflicts, and then we'll have more manual intervention on those very tricky projects on our core roadway network. But this is also going to set us up for the first time to have a statewide database as far as traffic control plans and or construction projects in general. So right now they're kept more on a local level, I would say, or on a district level. But having them digitally is going to set us up for the future to share this information through the work zone data exchange, the top bullet that you see there. It's going to allow us to do performance analysis, whether that's operations performance analysis, safety performance analysis on certain traffic control plans. But one day we might be able to turn static devices that don't have smart capabilities or geospatial capabilities to them into actual smart work zone capacities. So for example, if a cone, we know that cone is going to be set up per that traffic control plan, or that sign is going to be set up there, we could put in geospatial references that could be sent out to Google and Waze one day down the road. So moving more to that conceptual design of what we want to work towards, and we're very close to having this actually, and many states are working on this or have this in place, believe it or not, already. So we want to share our work zone and incident information in more real time over the cloud, or through the cellular network, or through a roadside unit, or RSU, you see in the bottom right hand side there. So I'm going to jump back to the left. You see OEMs or vehicles, generally after 2013, have connected vehicle or ways to communicate with one another and or cellular network. There's a lot of information that is being tracked. I hate using that word, but is being kept by the cars or shared between the two cars. And none of it is personally identifiable. And we actually at PennDOT explicitly say we do not want any personally identifiable information. It's actually one of our core data requirements. All we're looking for example, is heartbreaking events around a work zone, or windshield wipers on, traction control during winter weather conditions. So if we can pull that information into a data exchange or a data lake here at the DoD, we can start making decisions based off of business rules or use cases that we have for operations. So if we know a work zone's at this location and we're seeing a lot of hard braking occurring around a bad sight distance area, we could deploy and be reactive to put more protection messaging, or deploy a portable changeable message sign in that location to alert people better in advance that they're coming up on an incident like you see in front of you, or they're coming up on a mobile work zone, or they're coming up on a construction project in general. The worst part of our job is to see the incidents, to see people get injured, whether they're our workers or our public motorists. So the overall goal is for us to help to reduce that in general. So we think having the ability to take these terabytes of information in real time, calculate them, and then send them back out is the future. And we really think it's going to help promote connected and potentially maybe automated technology within vehicles moving forward. So where we're at, this is we're right around that Q2 time of 23. You know, we're July timeframe now. So we are in the testing phase of the new event management initial phase. So this summer we hope to go live with our first phase of the lane reservation system, but it's going to be a brand new event management system for our traffic management centers around the state. Concurrently, we will also be doing power user testing with a lot of the working groups that we were working throughout the last year and a half to come up with the design and then the systems engineering requirements. So we're going to be reconvening towards August, September timeframe to talk through policy, to talk through where this is going to reside and live within certain construction design maintenance processes. And then, is there any of those processes that we could potentially make easier or automate, or you know, something that it could just help alleviate concerns? So that's where we're at there. We hope to do some testing towards the end of the summer with outside partners, like I talked about, maybe some demos within construction and design. And then the end goal is to have some core roadway network construction projects or maintenance projects be entered into the new lane reservation system next summer, so summer 2024. So we are on schedule for this right now, and we'll just be working towards this moving forward. So shifting gears, now we're going to be going into incident management and where we stand with our EDC 6 efforts with FHWA. So we were talking about road work, which is an incident by definition. Anytime the capacity is reduced on the roadway, that's what we call an incident. So that's the segue into this one. So think of the lane reservation system. We're getting a new event management, incident management software to help handle this, and the policies to enter that information. And then this is the information and the data we've been using to help promote better TIM partnerships, or traffic incident management partnerships. So where did this all start? It all started with the TSMO performance program. So you can't really make improvements if you don't know the baseline of where you stand. So right now in our TSMO performance database, we have around 60 terabytes of information. Much of that comes from our PennDOT records. So those bulleted ones on the left, so our crash records, our RCRS system, weather stations, traffic counter way in motion database in partnership with the planning and research. And then a large data set comes from our ATMS, DMS message history. But it's all been correlated geospatially and temporally with our Waze incidents through our Connected Citizens partnership with Google and Waze, and then with INRIX. So they are our vehicle speed data provider, but they also have some incident algorithms in there too. So it's all been harmonized into something, into Power BI, but into something that we can make traffic operations or TSMO decisions on. So one of the tools that we have is the incident timeline tool. This allows you to essentially look at the timeline all the way down to municipality level of how long it takes to, on average, to clear incidents on certain PennDOT roads. Now, keep in mind here, we don't do a lot of the work when it comes to clearing. PennDOT doesn't do a lot of the work when it comes. these are partnerships, and these are teams of people at the municipality level and at the private level that are out there, from towers, fire police, and police in general, that really have to cooperate with one another or be on the same page to drive down these incident timelines. So what this does is just allows us to take a peek under the hood of understanding where could we potentially partner better, right? What municipalities are we missing, or what counties could we reach out to enhance our TIM practices? This is just an example of that. Now, this isn't done down to the municipality level, but green, yellow, orange, red, best to least, or best to highest number of incident clearance time. So red is 100, on average 180 minutes or more that it takes for those incidents to be cleared. And then green is 60 minutes or less, dark green. So now keep in mind here, just because it's red, it doesn't mean that they are not performing per se. It's essentially, sometimes resources are difficult. There's more rural areas out there. Troop barracks, PSP troop barracks can be further away. There's a lot of stuff that goes into an incident timeline or incident clearance time. But it allows us, like I said, to take a peek under that hood to understand where we can move forward. But to move this further, this concept further of understanding where certain conditions are, we wanted to look at another data set. And in my introduction, you saw to the TSMO performance database, we had our weather stations. So we have weather stations that cover 95% of our core roadway network right now. So we get every 5 minutes, we get readings of the weather all across the state. Actually, and one of the biggest partnerships that we have too is we share that information with the National Weather Service as well. They recently told me that's a partnership that they are not aware has been done between the DOT and the National Weather Service nationally. So PennDOT's leading that, and that's a great partnership we have with a sister office out of the Bureau of Operations. But we use that data, and we've compiled that data and correlated that data in our TSMO performance database to come up with likelihoods by certain weather conditions that we would experience crashes, whether they're commercial vehicle or non-commercial vehicle. So what you see there, that 2.2x or 3.2x for low visibility, high winds, freezing surfaces, freezing rain, slippery surfaces. We were able to define certain RWIS readings where we have increased likelihoods for these crashes. Why that's important is if we have these data stations, as I would like to call them, out there constantly collecting data for us, we have the ability to automate when these thresholds are crossed, protection messaging that they're approaching a hazardous driving condition, instead of those generic weather messages you see on our message boards. So what we did in some areas last year is pilot some whiteout messaging, and I'll go into that in a little bit, but we set a threshold, and it's on the left-hand side there. So you either had to have a snow or other form of frozen precipitation present in the actual calculation from the weather station. Visibility had to be, I think that's actually inaccurate. We put it under a mile. I need to update that. But, and then rain intensity had to be over a 0.04. Every time I've shown this to a meteorologist, they're like, well, I'm not sure about that. And I have to remind them that we're not trying to define a whiteout condition. We're trying to define that tipping point of when those crashes start spiking and we have whiteout conditions. So it is right on that cusp of a whiteout, and where we start to see a higher prevalence of major incidents, multi-vehicle crashes, long 3+ hour locations. So you can see on the graphic there, the 3 areas that are circled in red, we piloted automating whiteout condition messages for 15-mile radiuses around our weather stations. In conjunction with that, we've set up two weather variable speed limit corridors that have queue protection involved. And this is one in the graphic you can see on the right in the Clearfield area on I-80, and then we have another one on I-81. It was actually on the previous graphic you saw right there on 81 where it was circled in red. So that's what the VSLs, the portable VSLs, look like. We generally will only drop speeds if conditions warrant. So if you see those speeds dropped, please try to follow them. So moving on over to some more TIM outreach that we've been working on. So we have a new system for a video sharing. It's called MVIEW. Like I said in the beginning, we've had this around for about a year and a half, 2 years now. But as an overview, MVIEW is for first responders and public safety personnel, and it allows them to view all of our cameras or the cameras within their jurisdiction that they've been allowed to access to. So this can be viewed on desktops, laptops, tablets, smartphones. It's mobile compliant, but it's a partnership with the Maryland Coordination and Analysis Center through the Department of Homeland Security. This was at very minimal cost to the department, and I'm talking, you know, in the thousands of what we were considering. So, you know, a lot of video sharing solutions can be very difficult, and this has been something that has been very successful in Maryland and Virginia. Now, overall in the system right now, there's 15,000 cameras in all those different locations. Not everybody's going to have access to those in Pennsylvania, but what I'm trying to share with you here is if you are a municipality and you're interested in seeing our cameras, please reach out to us and we can help set you up with access to this. And if you want to partner with us and you have a lot of cameras that might help our TMC operations or our maintenance operations, we're willing to have that conversation with you all too, to bring your cameras into MVIEW. So this is what it looks like. I'm going to go over these pretty quick, but this is what it looks like. All the cameras are selectable. You can set up your own, once you start selecting cameras in your drop downs, you can set up your own virtual video wall. So if you're in a said municipality and you are only interested in your area, generally, you're going to set up these cameras up on your video wall and you can look at them all the time. So this is all over the internet and it's free of charge. All you have to do is reach out to my office and we'll get you set up with a video sharing agreement and you'll be good to go. So this is where we stand. I alluded to this pretty much and as I was going over that, but we're at the stage where we're at the red stage right now, where we're trying to grow our video source partnerships with other, you know, key partners. So we're set up a connection with the city of Philadelphia, and we hope to work with them potentially here in the future to get them an MVIEW. But we actually granted them access to our cameras directly. There's costs associated with that aspect, but we can talk through, we can customize any way you want a partnership with us if you're a public partner. So moving on. So crowdsourcing for advancing operations. So how we're using data to advance traffic operations. So PennDOT was one of the first in the nation or world to have a data-driven congestion pie chart. So this is 3 examples of what we've been able to do from a data perspective of quantifying where the congestion is occurring on certain regions or roads. So this is, you can drill down as far as municipality again on this. So you can see the Pennsylvania congestion pie chart. I'm focusing on that green wedge. So we have around 10% of the overall congestion impact score of around 10%. You go to the Philly Metro, it bumps up to around 27%. And then if you go to I-95 in Philadelphia, it's around 44 or 45%. So I think we all know intuitively, or if you haven't driven in Philadelphia, I-95 is pretty congested. So, you know, we've done these tests. It's had a lot of peer reviews nationally on our methodology and our databases, and this is checked out. So we're pretty proud of the data-driven congestion pie chart, and we want to give this information out to our planning partners and our design community to consider. But we can do more granular analysis. We can understand what congestion or what cause of that congestion, and then where our incidents are in that congestion. So we have done several different congestion related studies, but the example you see in front of you here is congestion related to a work zone. What we're able to quantify is once that work zone starts to experience congestion, how far back do we start to experience those secondary crashes? And not surprisingly, 45% of it is once the work zone starts to experience that congestion. It's a dangerous scenario where there's a lot of hard braking. But what was really shocking to us is 40% of those crashes happen 2+ miles back of the beginning of the congestion. And that, from an operations perspective, we want to start focusing on it. So if we could reduce 40% of those crashes, or the severity of those crashes, that's pretty significant to us. So you see those example messages in front of you. We came up with the concept here, and we have all the data. We started to design what we call data-driven or probe data-driven queue protection. Now, we don't actually have to have detectors out there. We use the INRIX data to build this information, and we use crowdsourced data queue protection. So what you're seeing in front of you is literally all we need to do this. So around 5 years ago, I started to design a project or an enhancement to our advanced transportation management system to build a corridors module. So one of the key requirements that I asked them to set up was I want the ability to use vehicle probe data to set up queue protection. So generally what you do is you geofence the area that you're interested in. That's represented in that graphic in the top left. So you see those E's and those W's and etc. Those are all of our permanent message boards or portable message boards that we could include into this queue protection. On the right-hand side, moving over, you can see that we have just the very rudimentary requirements of what we need to know. We need to know what resources you're interested in utilizing for your queue protection corridor, and then what speeds generally do you want these messages to automatically post when certain 1 mile segments drop below your threshold, for example. And that's what that graphic on the bottom left is supposed to represent. So there's 1 mile segments, and these, if this certain segment's experiencing drops under 25 miles per hour, the message boards upstream would be able to dynamically calculate 1 to 2, 3, 4, 5 miles ahead, stop traffic. So kind of, you know, going over some preliminary safety facts. I-78 was one of the first construction projects we turned on the virtual queue protection, and we looked at, so we did this in 2021. We turned it on we turned it on in 21? Can't remember now. I think we turned it on in 22. We turned it in 2021, but it was after these first 6 months. So we looked at 6 months in 2021 when it wasn't turned on, then the same 6 months in 2022 where it was turned on, and we saw a 12% decrease in crashes, a 23% decrease in the number of injuries, and 24% decrease in the number of possible injuries or worse. Generally, when we have any capacity taken on the roadway for construction, we are always, this is generally, we're always going to see an increase in crash rate. So if we can see any decrease, we're doing something correct. And I'm not saying that the virtual queue protection corridor is completely the one that helped with this, but because the district did a lot of changes here to make this more safer for people to drive through. But something's contributing, and then the overall partnership has been beneficial when we worked on the traffic control plan together. So we're at a point now where we have 20 plus of these probe data driven queue protection corridors deployed around the state. And it's a major cost savings, and it really increases the safety on projects who traditionally couldn't, pay for, hundreds of thousands of dollars to have queue protection and involved over the course of their project. So this is just more of a shout out for the next presentation that Scott's going to be giving. We have a new data set through a partnership from our Bureau of Operations and the Bureau of Center of Program Development. This year we purchased a statewide license for origin, destination, or trips data, where we can tell how many trips go from A to Z and everything in between. One key thing I want to call out here is any PennDOT consultant or partner business will have access to the information and tools. Now, the key to that is you have to be a member of the Eastern Transportation Coalition, and you must be doing work for PennDOT as a consultant. So a lot of multidisciplinary use cases here across planning, design, operations, traffic incident management, and then multimodal. So Scott will be getting into that a lot more, and he'll be talking about how to get access and give you some overview. But thank you for having me. Again, my name is Ryan McNary. I'm the Chief of Traffic Operations and TSMO Performance. And let me know if there's any questions. Thanks.
Good morning. My name is Scott Benedict. I'm the manager of the Traffic Systems and TSMO Performance Office for PennDOT, and I'm here to talk to you about an exciting innovation that we now have available for use in Pennsylvania, INRIX trip path data. So what is trip path data? Simply put, trip path data describes the movement of vehicles. It contains origins, destinations, and the waypoints, potentially the breadcrumb trails that define how a vehicle got from one place to another on a trip. You can essentially see an example of a trip path record graphically mapped here. This is a trip from to the Little League World Series in Williamsport from someone relatively local. You can see the whole path of their trip, every road they went down, and so on. This comes from GPS data, which is derived from connected vehicles and other sources like mobile app providers and other location-based services. INRIX has access to over 30 sources of this data, and it comes from a variety of sources that provide passenger and commercial vehicle data. This data is anonymized to protect privacy. We don't receive anything that would allow us to identify an individual vehicle. So what are some example use cases? I've put a number on here. I'm not going to go down and list all of these, but essentially this data has broad use across many transportation related disciplines: planning, design, traffic operations, anywhere where you would benefit from understanding how vehicles are moving, where they're going, where they came from, and how they got there. I'm going to show some examples related to traffic trends and diversion later on, simply because operations is our focus. So what are the benefits of this data? Well, first of all, it's real data. It's not modeled, it's not estimated, it's actual trips that took place on the road. Additionally, it's readily available. We have this data throughout the state, so it eliminates the need for manual study and collection, and importantly, it can also be used to analyze unplanned or unexpected events. If we have an emergency like the I-95 bridge collapse or some other thing that happens that we weren't planning on, and we want to understand how it impacted movement, there's no opportunity, for an unplanned event to go out after it's over and study and put out manual collection or do other things to see how traffic was diverted. This data is being collected all the time, so we never have to worry about it being available when we need it. It's also cost effective because you don't have the need for manual studies that, going out, putting out collectors, drone studies, all a variety of things you would have to do to understand, to understand the specifics of vehicle movements. So what do we have available? The data that we purchase is statewide, so we get any trip essentially that touches Pennsylvania, trips within Pennsylvania to or from Pennsylvania or passing through the state in any way. That's all in our data set, and we have data starting in 2022. We have the entire year of 2022, and as we go throughout the year of 2023, we have that data coming in as well. Data comes in monthly, so essentially we get data for a given month about midway through the second month, the following month. So, it's July, so we would expect to have received our July data by the middle of August. Who can use this data? Well, anybody associated with PennDOT can use it. Any PennDOT employee, anybody working for PennDOT can use it. We've purchased this data. Because we purchased the data through the Eastern Transportation Coalition's Transportation Data Marketplace, it's also available to Pennsylvania-based members of the Eastern Transportation Coalition. Now, if you're not sure if your organization is a member of the Eastern Transportation Coalition, you can go to their website, which I've seen here. Joining the Eastern Transportation Coalition is free, so there's no actual cost to use the data. So if you're not a member and you're eligible, you could sign up. That's a very simple process that's detailed on their website. And essentially, any public organization that manages or is responsible for helping to manage transportation systems are eligible to be members of the coalition, such as transportation agencies, municipalities, police and emergency management agencies, planning partners, and regional and metropolitan planning organizations. Chances are, if you're on this organization, if you're with a public organization and you're on this call interested about transportation innovations, you're probably eligible to be a part of the coalition. Consultants and universities who are doing work for PennDOT or coalition members can also have access to the data on a project-by-project basis. In addition to the data itself, we have access to tools for using the data, and those tools reside within the Trip Analytics platform, which is a web-based platform that was developed by the University of Maryland. They update it, they maintain it, and they get our data into it on a monthly basis. I've put the address here. There are a number of tools within the Trip Analytics platform that we can use to analyze analyze this data and understand vehicle movement. The first is the traditional origin destination matrix, which essentially just will show you, your origin and destination pairs, your most popular, beginning and ending points for trips within whatever study you do, and that's broken down by zone. And when you're defining studies within Trip Analytics, you can use a variety of different zones. There's predefined zones. You can have your zones be counties, zip codes, states, municipalities, transportation analysis zones, or TAZs, and you can also custom define zones with your own shapefiles that you can create. I have an example here looking at an origin destination matrix by county for trips to Hershey Park Stadium for the Lady Gaga concert last August. You can see here, again, these are all trips to Dauphin County, since that's where the Hershey Park is, but you can see what counties they came from and analyze the data that way. Another tool that we have is the zone map, which provides a visual analysis of that origin and destination. This doesn't show you necessarily pairs, but this is going to show you, it's essentially a heat map that shows your most popular origins and destinations. Here's an example that I pulled, trying to understand kind of the before condition for the I-90 when I-95 collapsed. Had the bridge collapse in Philadelphia a few weeks ago. We were trying to understand, generally speaking, where traffic that was going through that area was heading and was going to and coming from. You can see this, the orange areas, this is for northbound traffic, the orange zip codes, this was by zip codes, the orange areas represent the origins, the blue areas represent the destinations, and by the darker colors, that would show you the areas that have more origins or more destinations. The third tool that we have is the ability to do detailed route analysis, basically provide a route map. So you can literally see, when you run a study, you can literally see, all the routes that were taken based on your study for all the trips that came in. And so you can also see the average travel times for those routes, so you can understand if you're looking at before or after studies or things like that. You can see the impact of whatever it is you're looking for. One of the most powerful parts of this tool is the screen line analysis, which essentially allows you to, once you have your routes in front of you, you can run a screen line, and any place that crosses a route, you can see what percentage of the trips that are on that screen line crossed at that point. This is an example we did for our PennDOT District 9. They were interested in seeing what percentage of folks that were going to the Pennsylvania Turnpike from US 219 used either these two exits. They were considering some signing changes. You can see from this, essentially it was a 50-50 split, 47-53. So people were using those exits pretty well equally, and we were able to provide that to the district, and they were able to focus that and put that into their planning. So I wanted to give you kind of a hot off the presses example, more of a detailed study of what we've been able to do. And this, as I said, I'm sure everyone's aware about the I-95 bridge collapse and how that I-95 was closed in that area for a couple of weeks. So we wanted to kind of understand the impact of traffic on there. So I did a study. We identified using that zone map that I showed you earlier, the areas of the city that where people that were using 95 to go through the bridge collapse area before the bridge collapse occurred, where they were going from and coming to within the city. And so I created these from and to zones you can see on the map to the left. And when I was what I'm showing you specifically here looks at northbound trips. And you can see from the data, prior to the collapse, the week before, on the weekdays, the week before the collapse, you can see about 76% of the people that were going northbound from the from zone to the to zone were using I-95. Obviously, that option was no longer available to them in the week after. So we were trying to see what the change was, what routes people were actually taking. And you can see that data as well. One thing that was interesting, total trips decreased by 38% from the one week to the next. Now, that was probably a combination of people deferring optional trips, but also, possibly some less data in the set because this was kind of a special provision of data. We don't usually get the data that quickly, so we were missing a number of sources, and so that was the case with that. But despite the fact that we had 38% less trips overall, you can see we had a 158% increase on these main primary alternate routes, which were US 1, PA 73, US 13, and Torresdale Avenue. Additionally, US 1 and PA 73 were the PennDOT and the city local detour routes. So we can see from our study that 67% of travelers the week after were between these two zones were using the approved and official detail tour routes. The other thing we found was that 46% increase in the travel times, which is about 12 minutes on average, which is not ideal, but for a major interstate collapse like this is also not perhaps as bad as you might have expected. So an obvious question you're going to have, I'm sure, is how do you get access? If you're a PennDOT employee and you're watching this, you can get access to this right away. You can go to www.ridus.org/register, create an account. You'll be automatically approved for access, and then you can go to trips.ridus.org, your address I showed earlier, and start working with this tool. If you work for a different organization, it's possible you can already do that if you're a coalition member that's already signed up. But the simplest thing to do, just to understand, is to just contact me for information. My contact information was at the beginning, and I'll have it here on the next at the end of this presentation as well. And here is my contact information. I want to thank, if you need it, to reach out after the presentation. I will also be available for questions at the end. I want to thank you all for your time, and have a good day.
Thank you for your presentations, Ryan and Scott. It's great to hear about the innovative tools PennDOT has available to ease traffic congestion and improve safety and reliability on Pennsylvania roadways. Now we'd like to hear from you, our audience members. If you have a question from one of our presenters, please enter it via the chat box in the lower right-hand corner of your screen. Anya Walker from the Bureau of Innovations will read them. Panelists, please unmute yourselves. Anya, what questions do we have in the chat for today?
Thanks, Jacqueline. Yeah, well, we'll wait for some of the questions to come in here through the chat box. Just a reminder to please send the questions either to everyone or to the host and presenter. And then Ryan and Scott, also, if you see questions that were sent directly to you, feel free to read them and answer them. So as we wait for the questions, I do have a few here. One is geared toward the lane reservation system, and that's for you, Ryan. So who's going to be required to submit reservation entries into the lane reservation system once it becomes available?
Oh, okay. Well, hi, Anya. How you doing? So basically, think I said this a couple times. Anytime we're getting capacity removed from the roadway, we want to make sure we're capturing that. So how we're going to accomplish that is we are going to have a public facing aspect of the lane reservation software in phase 2. So we hope to grant access to any entity at that point. So simple lane reservations can be entered by utility companies or private contractors, for example, if they're the administrators of major construction projects. So the short answer is everybody, we hope, and cross our fingers, but we got to walk before we run. So that's how I would like to answer that, at least for our core roadway network. So there's 4,000 miles of routes that I talked about.
Okay, wonderful, thank you. Another question that I have here is, have you been able to see similar data from the I-40 Mississippi River Bridge closure in Memphis from 2 years ago and make comparisons to the I-95 collapse in Philly?
No, we've not. We do not have access to. We only have access to data in Pennsylvania. So at this point, we've only been able to look at the I-95 data, and the reality is, I mean, and that's even still somewhat preliminary because we're being provided with an advanced data set.
Okay, thank you. Okay. Scott, what is INRIX's data coverage like in terms of how many trips they capture in Pennsylvania?
INRIX, I mean, and there's some variability here, you know, by area of the state and so forth. They have said that they cover about 12, their data sources cover about 12% of the vehicle miles traveled in Pennsylvania. Now that is currently in flux. There's one of the major providers in the space recently went bankrupt and they're missing that data at this point, but that's the general ballpark of where they're at.
Okay, thank you. And then is there training available on the TRIPS analytics tool?
There is. We had a training back late in the winter that we recorded. We have that available to anybody that's interested in that. Anybody that contacts me, I can get that to them. And we're also looking into doing some further training. And again, anybody that contacts me about that, we'll make sure we get you in the loop for that going forward.
Okay. Awesome, thank you. And then one more question I think for you, Scott, is can you elaborate more on the process for organizations other than PennDOT on how to get access to the data?
Yes, sure. Essentially, like I said in the call, you would have to first become a member of the Eastern Transportation Coalition or be a consultant or university doing work for PennDOT or for an Eastern Transportation Coalition member. Once you've done that, then there is a data use agreement that has to be put in place. As a result, you know, it has to be put in place. That's an electronic process. You would have to go and fill that out for your organization. If you're a consultant, you would have to specify, you know, the contract or project you're working on for the coalition member as part of that process, and then, you know, submit that. It usually takes the coalition, I think they say it takes up to 2 weeks to respond, but they will usually take can just take a few days. And once that data use agreement is in place, then you would their support would authorize users from your organization to be able to access the data through the Trip Analytics tool.
And Scott, I think we would say if you are interested and you're from the consultant community, you can reach out to us and we can help walk you through that process. Or if you're a designer that works with consultants, for example, we can give you a walkthrough or an easier way to share this information and get people set up.
Sounds good, thank you. That's all the questions that I'm seeing so far here in the system or in the chat box. Ryan and Scott, I don't know if you have any that came in through privately to you. If not, I would kick it back over to Jacqueline for the closure.
Thank you, Anya. We had some great questions for our panelists today. And if you still have a question that hasn't been answered, you're always welcome to submit your questions to .innovations@pa.gov. and we can work with our panelists to provide responses to your questions following today's webinar. I'd like to thank Ryan and Scott and all of you for participating in today's session. And we have a quick feedback survey that we'd like you to complete. I'm placing the survey link in the chat box right now. Your feedback is very valuable to us and will help us with planning future events. I would also like to remind everyone of our upcoming webinar series dates for this year. On September 12th, we have a webinar that will cover driver and vehicle services. It's leveraging technology to enhance the customer experience. And on December 12th, we have a webinar that will focus on PennDOT's digital transformation. If you have any innovative ideas to share for future webinars, we would love to hear from you. Please send your ideas to .innovations@pa.gov. We want to just thank you again for joining us today, and we look forward to your participation in future webinars.